What's interesting is ice used to be a luxury. To have ice in your drink,
right.
You had to be a duke, or you had to have a staff to go out and get ice blocks from a lake in the winter and store it. You see what I mean? People don't think about this correctly, and the future's here. It's just not evenly distributed. One fear I have is that we're not going to update our cultural operating system quickly enough. And here is where we can learn from aristocracy. What did people do all day when they didn't have to work?
We're going through something absolutely historic.
Technologies across the board are growing exponentially.
It's a disruption that's going to completely redefine the way businesses compete.
In the next decade, we're going to lose 40% of today's Fortune 500 companies.
The exponential growth of computing is continuing.
AI is nowhere near its full potential.
Whether you like it or not, that the future cannot be stopped by anyone.
Welcome back to the Future Tech and Foresight podcast. I'm your AI host, Mark Verbenkoff's deepfake avatar, and this is episode number 235. The corporate AI landscape is shifting away from single-vendor dependence on tech giants. While mainstream narratives remain obsessed with massive general-purpose models, scaling enterprises are hitting walls with soaring token costs and security risks. This episode explores how forward-thinking organizations are adopting specialized, task-specific small language models, SLMs, and model ensembles to achieve redundancy and absolute cost control. We unpack the impressive economics of AI inference, showcasing real-world case studies where businesses cut monthly compute bills from tens of thousands of dollars to just a few hundred. Looking ahead, we discuss how AI agents will eventually mature into ubiquitous, invisible infrastructure, much like the internet or modern operating systems. From evolving job descriptions to the rising energy demands of data centers, this conversation maps out how to strategically position your operations for a decentralized, multi-provider AI future. A little bit about today's guest. Calvin Cooper is the co-founder and COO of Neurometric AI, a pioneering company optimizing cost efficiency and performance for multi-model AI systems by intelligently orchestrating inference time compute. He also serves as an advisor to Pilot Wave Holdings, leading AI automation strategy across industrial sectors, and as an advisor at the Milken Institute focusing on capital markets policy. Previously, he co-founded and served as CEO of Rove, a Fintech company that democratized real estate investing and went public via a NASDAQ direct listing. His work has been featured by the White House and Fast Company, and he co-hosts the podcast Inference Time Tactics. Through his work, Calvin continues to explore how intelligence, capital, and policy intersect to shape the next era of innovation. Great. Well, Cooper, thank you so much for coming on to the podcast today. I am very much looking forward to the discussion. We're going to touch a little bit on kind of what's happened with AI, talk a little bit about the infrastructure, and maybe even like how the human layer is connected into here. So looking forward to getting your insights on what's going on. Thanks for taking the time to talk today.
Thanks, Mark. I'm excited to dive into the conversation.
Yeah. So you started Neurometric, but maybe we want to talk a little bit about the previous work that you've done that led into what you're doing today, because I think you have a little bit of an interesting background. So if you want to start us off there, I think that'd be a great place to start.
Yeah, absolutely. So I started my career in venture capital, helped raise a fund in the Midwest, in Columbus, Ohio, and brought in a few banks, which created the role and invested across several thematic areas. So health IT, smart cities technologies, blockchain technologies. And this is about 10 years ago. So then I quit and started Rove, RHOVE. It was a consumer fintech business. Raised a $10 million round from Drive Capital. Built that business, got qualified by the Securities Exchange Commission as a serious issuer of securities, and then sold that company 3 years ago with the plan to take the acquirer public via direct listing on the NASDAQ, which we did. So I've run the full lap. Raised capital, invested as venture capitalist, raised venture capital, build a company, sell a company, and then think about what's next. So often when I'm looking at an opportunity, it's with that venture hat on. It's okay, what's changed in technology and consumer behavior, but not something temporary, something that will endure. What's changed in the regulatory environment? So what has changed that made new opportunities possible, right? And specifically in adjacent possible. And so what's really interesting about AI is there has been some incredible breakthroughs in the past few years with LLMs. And I remember back during my time in venture, I hated AI
Oh,
pitches
interesting.
back in the. I hated it because it wasn't true AI, right? You were just, oh, this is AI, but really you either had duct tape and bubble gum with humans doing it, or you had decision trees with automation, but it wasn't interesting. Most stuff wasn't interesting. But now when you look at the landscape, there's so much to do. And so when I moved to New York, I was introduced to Rob May, our CEO, through a mutual friend. I was advising an AI startup out of the Midwest. She knew we were both moving to New York, him from Boston. And so we became quick friends and started looking at this inference market, and got really excited and decided to join as a co-founder. So I'm co-founder and COO at Neurometric. And our mission is to make inference essentially free. So today that looks like building and hosting task-specific small language models for enterprises and developers.
Interesting. I know that we talked about this before the recording, but can you just maybe clarify for some of the audience members, like what you mean by inference?
Yeah, so inference is the phase where like a trained model is like processing input data to generate an output. So think about that like when you're prompting or asking a question in Chat GPT. What happens next is inference time.
Right. And you said small language models. Why not a giant one? Why not the big ones? What's so interesting about small language models?
So finally, the market's catching up to what we got to, what we saw through first principles. So what's interesting is like even early last year when we were just looking at it, you're reading these dense papers out of like archive, computer science and research. But the headlines are really, really around OpenAI train a new model and it can do all these incredible things, right? So you read those headlines and then you see more and more headlines coming up from other people like Anthropic. And this is really around training. It's like larger and larger models that have more information. They're better at responding to your prompts. They can do more things. But we saw a very underdeveloped or noticed part of the market with inference, right? And in our research, we found that inference time compute or algorithms and your approach to prompting a trained model or searching a trained model could have as much or a bigger impact than on the output than which model sometimes. Is it this one or this one, right? And so all the leaderboards that are measuring performance against benchmarks, they're like one shot like this model or this model. But then when you layer on different approaches like best of N, like hitting a model multiple times, and then taking the most common response is one approach, right? There's just so many different approaches that matters. And then also, and this is really obvious when you think about it, but still people are like, oh, can small language models beat a large language model, right? So a large language model might be trained on all of human knowledge, right? So do you really need to understand world history or rocket science to schedule a meeting? You know, and so what you find is that a small language model fine tuned towards a specific task is not just 10 times or more cheaper. It's also significantly faster and more accurate. So you can
Right.
go from 75% accuracy to 98% accuracy because you've trained a small model just to do that one thing, right?
Awesome. And I guess this is also where like the skills in agents like Claude's bots, for instance, people are starting to understand that this is what's useful. It's not the, as you said, the giant know-it-all LLM. It's specific agents or specific back in the day GPTs that you can train on certain aspects of, say, your business or on your career, that's able to give more fine-tuned responses to what it is that you're actually looking for, rather than something a little bit more generic.
Yeah, exactly. And so we saw this is where the market's going, but then it's this is such a huge market. We're just not even 1% into the impact that AI is going to have on the world. And a lot of times the conversation around who's the best, or is it Anthropic versus OpenAI versus, Google or Gemini, right? It's the wrong frame. All the Anthropic is scaled to billions of dollars in revenue a month, even as OpenAI continues to grow, right? And the other players are growing. And that's true at the model layer, and it's going to be true at the chip layer, right? So NVIDIA is going to continue to grow even as alternatives grow in the market. And even as other, on the model side, small language models enter the mix. So it's not a this or that type of winner take all market. And when you start to think about how actual enterprise systems are being built for scale, then it becomes obvious that this market is going to be composed of many players.
And then when we're thinking about like not just the like OpenAI or Anthropic or Google, but like large players, in the pre-recording we talked about like the Department of Defense or AT&T or any of these larger corporations. They're probably not just looking at just ChatGPT or just Perplexity, right? They're testing a number of these different current leaders and figuring out which is going to be useful or a combination of them, right?
Yeah, so many things drive this. So, like, I studied economics in undergrad, and I continue to publish policy and economics research. Like, I'm a researcher outside of the computer science world. That was before, that's just something I've always done. And you can predict a lot of things in the future by understanding a system and its incentives, right?
Right.
If you really understand all those dynamics, it becomes obvious what's going to happen. So even before you see enterprises do this, or corporations or governments do this, it's going to happen, right? So even if the dominant conversation or thesis with VCs, even some of the smartest people in the world, I don't understand how these companies are going to beat Anthropic. You just got to think about the incentives and the structure of the system, right? So there are multiple reasons why AI systems are being developed, and it's not just a one vendor conversation like an ERP system, right? So I think you mentioned the Department of Development. This highlights one reason that's even non-financial, right? So if you recall, Anthropic got into a big fight with the Department of Defense because they wanted to use Anthropic's technology for different defense purposes that Anthropic didn't want to be used for. So what's kind of interesting is then you have the government basically threatening Anthropic at first, like, oh, well, then our contractors can't use you guys, blah, blah, blah. And they have this dependency, right? So what's unsaid there's a vendor dependency to meet a national security interest. Okay. So then OpenAI comes in, and then they're going to do business with the government. And so then you have people talk like, oh, delete ChatGPT because, and you have the Secretary of War and two CEOs deciding how technology is going to be incorporated into our government. So that's just one example, but think about enterprises, like decisions by a vendor that impact your critical systems. That's not good, right? You can't have that level of vendor dependency when you're starting to integrate technology into your critical systems. Okay. So that's one reason why people are like, okay, I need to then abstract away model choice. I need to make that a commodity. I need to have redundancy. I need to pull different capable models from different model providers, closed or open source or proprietary, to meet an objective, right? So that's one reason. Another might be, there's a bottleneck around compute, right? So there might be some things around availability. Another thing is around cost. So what you see in every organization is that at first you're just trying to get something to work. Maybe your CEOs just turn into the exec team, like, what are we doing with AI, right? Everybody has to do something. And you just have pilot projects. And at first in the media, I think last year, we were at the point where 95% of enterprise pilots were failing. And people were like, hope that up, like, oh, see, this doesn't work, which is crazy because the future's here. It's just not evenly distributed. So the 5% was working. And a few years ago, what AI deployments were working at all? So now it's growing. And so what happens at first is you're like, pick a vendor. Okay, we're going to leverage OpenAI's API or Anthropic's to do a thing. And then once you get it to work and you've proven a use case and you go to scale, you start to have some of the issues we talked about before, or you start to see pricing issues. Like AT&T was just in the press and VentureBeat talking about they went from 8 billion tokens a day to 27 billion tokens a day, right? And that can be really, really expensive. Even if you have in place, like some of the primitive ones that people might use, like prompt caching or different things or volume commitments, you're still looking at millions of dollars a year in spend for just one use case. And scaling, right? Scaling rapidly. And there's an ROI there, but now you start to say, okay, efficiency becomes a thing. So what can I do to lower those costs? And different model providers are not incentivized to route you to the best model in the world on the right hardware at the cheapest way. They want to keep you in their family of products, right?
Right.
So even if they can reduce your spend there, but then grow it overall, as you scale AI across the organization, you're leaving a lot of money on the table. So organizations with the budget and the expertise start to build an orchestration layer and incorporate not just different models from frontier labs, they're also incorporating task-specific, fine-tuned small language models. And so I think that article in VentureBeat is really enlightening. Andy Marcus, if you look it up. But that's just the template. That's what people are doing, and that's where AI is heading next.
So that's why you and your co-founder developed Neurometric to get in on this upcoming or starting orchestration infrastructure, if you want to use that term, for these smaller LLMs that are maybe a question. Do you find that they're going to start to replace the usage of these larger LLMs, or is it just going to be, as you said, like a rising tide kind of lifts all boats and they're all going to be used?
They're all going to be used, but it is already taking tasks away from large language models. Like today, we have customers doing that. And we've been doing that for 6 months. And so like last year, we all went full time in August, right? And some of this was theoretic, like conversation early last year. And then there might be like a few expert tech companies heading in that direction a while back. Now you're just seeing people talk about it in the press, and it's becoming more understood, but it's still not the dominant thesis. People are still talking about large language models and this or that, but it's just obvious. So like when you see a big market and you have like a secret, basically, like you see something that others don't. And here's what people get wrong about entrepreneurship. You're not like not listening to reality, being arrogant. It's the opposite of arrogance. It's actually being observant. So people who are like, oh, that's not gonna happen. It's like, yeah, but like, here's the system and incentives. Here's the logical rationale. Symbolic logic is useful here. And then here's an example of somebody doing it, and the future's here. It's just not evenly distributed. And then you can just ship as quickly as possible a test. So, you want to validate your hypothesis, but it's more than an educated guess. And so then we put up a leaderboard. You're demonstrating empirically that ensembles of models or models plus different algorithm inference time compute approaches perform better than just a frontier model, right, against a given task. And then you iterate from there. You start to work with real customers. And then now we're fine tuning and hosting small language models for people, like one customer. And we'll talk about this on our podcast, Inference Time Tactics, soon. But like they were spending, tens of thousands a year, like I think growing for and AI automation around resume parsing, and they they come in, ask for a custom SLM around that. We shipped it. It's a couple $100 a month. So they 10x decreased their costs. And here's the kicker. He was like, that alone would have been cool, but we improved the accuracy of their system from 75% to 95%, above 95%. And that's against GPT 4.0. So
super interesting. Maybe also to connect this to kind of the larger discussion that's happening right now with data centers. So these smaller language models are cheaper. I'm also assuming they are maybe because, or the reason that they're cheaper is they're less energy intensive, they're less data hungry. Can you just connect this, shall we say, this newer trend of smaller language models to kind of what we're seeing today? Like, are the larger, these giant mega data centers necessary for smaller language models to function?
Ultimately, you're going to need compute on your device, or you're going to need inference time compute on the edge, right, in your refrigerator. So there's many use cases where AI is going to be pushed to smaller compute resources, and you just can't run a big, large language model. You're going to have small language models as part of this mix, right? But in terms of energy and how we think about this, something really dangerous is happening in our public discourse, where people are getting booed at commencement speeches because they mention AI, or half the data center projects that are proposed are being canceled because of local resistance. You have bills, really, really short-sighted, idiotic bills being introduced by politicians in Congress to put a moratorium on building data centers in the U.S. based on, BS. And I understand and get it, if somebody's bill, if the energy bill is going up for consumers, that's a concern. We can address that in different ways. You had hyperscalers agreeing to take on that cost, right? That's a much better strategy, but it is really incremental when you consider what we need to do, right, with AI. And when I say what we need to do with AI, you now have people getting access to educational resources that they wouldn't have access to for free. We have access to healthcare resources that we wouldn't have had. You're now starting to see some scientific breakthroughs with AI augmentation. So this is a really, really important investment for our country, and we don't execute in a silo, right? We are in a multipolar global world with other people building data centers at scale. And the majority of Chinese citizens are optimistic about AI, and the majority of ours are very, very pessimistic. And that can have some dire consequences for American economy and ultimately our national security and prosperity for years to come. So to answer your question around energy, we do need to scale our compute resources and build more data centers. Absolutely. That's one part of the challenge. The other part of the challenge is we need to use what we have built more efficiently. And so much of the GPUs we already have go underutilized, and much of the current spin on AI inference is going to models that they don't need to. It's just too expensive and unnecessary. So you're already seeing a shift to smaller language models to address that. But Jevons paradox applies here. So even as we get more efficient, we're going to use more and more AI resources.
Yeah. Yeah, it's the you increase the bandwidth and then the usage increases, and you're constantly trying to increase things. Super interesting. So when it comes to like looking out in say 3 to 5 years or so, are you seeing kind of a change in the amount of usage for these giant LLMs? Like you were saying, Anthropic, OpenAI, Gemini, they're all growing. Is the rate of their growth going to change over the next couple of years? And
I'm super bullish.
Yeah.
I think they're going to continue to grow. I mean, like I could just say, even with our customers, okay, they might shift this spin to us, and then that's growing. They're like, okay, I need more endpoints. As they find other ways to deploy these other models, like the frontier model providers play a really important role around pushing the capability ceiling. And they too are introducing smaller models and different things and building applications to solve different use cases, right? So this is going to be a really, really dynamic market.
Yeah.
And we have barely scratched the surface. We have not even begun to solve the problems that we can solve with AI that have already been proven.
Mm-hmm.
Like we haven't even adopted what's been proven to work yet.
Right. Yeah, I'm also incredibly excited about the future of this. Yeah, like it could, from so many guests that have come onto the podcast that have talked to me, it could, and maybe it already is, but it could, bring about a new golden age for humanity, right? If we were looking at like really kind of meta ideas here, whether it's scientific breakthroughs or maybe new engineering principles or all these kinds of interesting things that could really come about. and I guess you're just as positive, you're just as optimistic about this growth of AI. Can
The
we
possibility,
yeah. Could we maybe shift? I want to connect this idea of, what everybody's talking about now is the agentic age, right? All these agents that are being deployed. How do agents connect with these smaller language models? Like, are they synonymous? Are they deeply connected? What can you kind of tie that idea in my mind?
I love how great we're at labeling things in the software the venture industry. Yeah, an agent is just like the full system, right? It's leveraging an LLM and increasingly many LLMs and SLMs. It's got memory, planning, tool usage, right? So basically, it's executing tasks and doing a thing,
Mm-hmm.
right? So one big breakthrough that has brought this really to the forefront is you've seen OpenClaw, right, explode, and people are automating tasks like bookings and messaging and just content creation and different things. So you could just think about an agent kind of like executing these complex tasks and workflows, whereas like an LLM is just like it's a next token predictor. It's one component of an AI agentic system. And there are many different models, small language models, world models that people are starting to develop. You've got many different things, right? I think in a few years, the public will not be thinking about large language models or small language models or these things, right? They'll be thinking about the impact or the applications or the brands.
So you're saying it'll just be, I'm trying to think here, like an operating system. People don't really think about operating systems. They just kind of use it. It's on the device that's given to them.
Oh yeah, remember, so Windows 95 was a big deal, right? And,
Right.
if you think about the evolution as an analogy of social media, I remember when I was in middle school, learning some HTML, designing that, or working on a website for my dad, having to learn how to code. Now everybody has social media. Nobody writes any code, doesn't even think about that, right? Nobody's personalizing their MySpace page. Um, it's all been abstracted away. So today you have a lot of people tinkering and they're excited about OpenClaw or Hermes, or they're thinking about different model releases from different providers and what's an agent. But in the future, people aren't going to think or care about that at all unless you work in the industry.
Yeah, it's just going to become a ubiquitous layer that is useful, that has impact, as you were saying. And these
Right.
maybe even a better example is, how does the internet work? I don't understand the deeper technical ways that it works, but I use it all the time. I'm using it right now. I don't fully understand how it functions, and I think that the argument here is, the same thing is going to happen with AI in a couple of years. It just depends on how quickly, whether it's your company or others, are able to make these tools as simple for the general public as possible. And ChatGPT and these are already there, I'd say.
Yeah, already for search, you've got one use case, right? Conversational search essentially is nailed, done.
Yes.
Right. And it's very, very useful. I think AI isn't one of these things where you can layer on morality or should we or shouldn't we do it. It's happening. And just like the internet, every company is an internet company now, right? You cannot operate your business or sell your product or services without being on the internet. It just doesn't happen. Or mobile, everybody has a cell phone. Everybody operates through their mobile phone. Every service and product is delivered through a mobile phone in some way or connected to. Your taxi driver can't get paid without a mobile phone now. Similar with AI, right?
Yeah. No, completely agree. I see that the time's winding down here. I think we missed one thing, and maybe this is also an interesting way to end the conversation. The human layer. So we've been talking about LLMs and AI almost within a bubble, I would say. How do you perceive the human interaction with AI over the next couple of years? You touched on a little bit with, the emotional fervor that people are trying to shut down data centers. But how do you see that? Like, humans are going to be kept in the loop. Humans are going to be essential. They're going to be moving to more higher level tasks. They're going to be replaced. What's your perspective when it comes to humans and their interaction with AI?
We're already automating tasks. A job is a bundle of tasks, right? So AI doesn't eliminate all jobs, right? It eliminates tasks, and especially easy to automate are those that are rote or like very SOPable, right? Standard operating procedures, like where you just don't think and push a button. But this has happened before, like in factories, you could just go push a button and raise your family and retire. But the reality is most people don't want the job that AI is doing, right? So think about an analyst role, the grunt work that you had to do building these spreadsheet ninja or some of the early market landscape and memo writing I do as an associate in venture has been automated already. And if you haven't adopted it, you're just slow. It's gonna happen. But the industry still exists, right? So the job shifts. And so the important thing is to use AI products as quickly as possible and incorporate it into your life, just like, in the past with the internet, right? Or learning how to type. Are you going to get a professional job if you can't type? And so it's a similar thought process. And even at scale, I think we overestimate what we can do in a year, is the saying, but underestimate what we can do in 10. So even imagine a world where AI and then embodied AI with robotics is just absolutely ubiquitous. What would happen? Okay, maybe we can make housing so cheap and abundant and affordable that you don't need as much money, right? And every product is already getting cheaper. There's only a few sectors where things are radically more expensive than they were a few decades ago, and that's housing, healthcare, and education. Okay, and so housing is a function of what? Labor, cost of capital, materials, and government regulatory capture and policy. That's a big one. And so we can start to actually decrease the cost of building housing. If you could think about healthcare delivery, already AI is starting to be useful there, and stupid policy being introduced in New York to ban the use of AI in healthcare, which would be quite negatively impactful to the people who already can't get access to healthcare. But we can absolutely make an impact and already are there. There's some great success stories we should elevate. And then education. You can learn anything on the internet. And now you have a tutor that can do it in a conversation. It's amazing. So lastly, I'll say, imagine if there is less jobs, right? The amount of hours you work at a job is partly a function of policy, right? The 40-hour work week was an invention, right? Could you imagine a world where you had 20 hours that you put in and you get the same kind of thing? What's interesting is ice used to be a luxury. To have ice in your drink,
right.
You had to be a duke, or you had to have a staff to go out and get ice blocks from a lake in the winter and store it. Like, you see what I mean? People don't think about this correctly. And the future's here. It's already, it's just not evenly distributed. One fear I have is that we're not going to update our cultural operating system quickly enough. And here is where we can learn from aristocracy. What did people do all day when they didn't have to work? Invented things, read things. They wrote things, War and Peace. They created art. They did all kinds of industrious things. It's philosophy, So maybe, just maybe, we should not build our whole meaning around a job. And technology is going to set more people free from that.
Perfect place to end the episode here, Cooper. Thank you so much for coming on. We'll have your website and company Neurometric up on the show notes, your LinkedIn. Do you want to have anything else up there where people can follow and reach out to you?
Or Cooper_NYC_. Or connect with us at neurometric.ai.
Perfect. Thanks so much for coming on, Cooper, sharing your insights. And I think reiterating the potential golden age that so many guests have come on, and trying to infuse my mind and the audience's mind with this kind of positive outlook of the future. Thanks for taking the time.
Thank you.
Well, thanks for listening to this week's Future Tech and Foresight podcast. If you like what you've heard here, there are, of course, a number of ways that you can support the podcast. The best way would be to leave a review on Apple Podcasts or give a rating on Spotify, which you can find a step-by-step explanation for on the futuretechandforesight.com website. Alternatively, feel free to leave a comment either on the episode show notes or the YouTube channel where you can see video recordings of the interviews. And finally, if you are part of an organization that is aware of the disruptive and transformational impact that emerging and future technologies will bring and want to know more, please get in touch to hear about the strategic foresight services that we offer and how we can help future-proof your organization and take advantage of the phenomenal opportunities available to survive and thrive in the future.
A lot of future-shocked people and future-shocked institutions in our society are simply overwhelmed.
Once there is superintelligence, the fate of humanity may depend on what the superintelligence does.
Science fact is catching up to science fiction.
The first truly intelligent machine will be the last invention that humanity needs to make.
The only scarcity that will exist in the future is that which we decide to create ourselves as humans.
Within a 10-year design revolution, we can have all humanity living the highest standard of living anybody's ever known.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity.
We are probably one of the last generations of Homo sapiens.
Every single headline points to the birth pangs of a Type 1 civilization.